All right. Hi, everyone. My name is Conrad Stoll, and I'm an architect at Mutual Mobile. And I'm here today to talk to you about demystifying security best practices. And so I think we're all here because, we all want to make secure software, right? We're all making mobile apps that ship on the App Store, and we want to make sure that they're secure. Well, the good news is that that's actually really easy, so we can all go home early today. All you have to do is when you ship your app, you ship one of these little locks along with it so that all of your users have to lock their devices up and keep them at home and have a passcode and all these types of things. But, the reality is that that's just not really the way things work, right? That mobile devices are inherently not secure, that they're out on the street, they're in our pockets, they can be stolen, they can be lost at a bar. So there's no way to know if the user has a passcode. So this is a very challenging thing, right? Security is actually very hard. But even though it's hard, we're still expected to secure our software, right? That this is still something that both our clients, if you're working for other companies, or our users or their users, they still expect for our software to be secure and for their data to be protected. So this is our office. I said I work at Mutual Mobile, and so I know a little bit about security because we've worked with some big clients that security is a big part of what we're building. We're building mobile banking apps and apps that deal with medical information. But one of the things I actually want to emphasize is that, like you all, I'm an application developer. I'm not a security researcher. And so with all of these products that are very user-facing, very user-focused, security is a feature. But it's not like the only reason we build software. And this is because products are really judged by the user experience, but also the absence of security issues. That, if an app has a really great user experience, but it has all of these issues with security that become publicized on the web, or that somebody loses their data for some reason, or has a fraudulent bank transaction, that's going to really impact their experience using the product. So that's kind of why this is so important. And it turns out security is really hard. How many people have seen this little phrase before? Right? So this is go to fail, right? It's an issue that Apple had a couple of months ago that fundamentally broke SSL, right? I mean, this is a core technology that is a major part of internet security these days, and it was broken. It did not work. And I mean, this just goes to show that security is a hard problem, and that's why we're all here to learn about it, because it's difficult to do it well. And jokes aside, Apple actually does take security very seriously. How many people have seen this paper, the iOS security white paper it's actually been published for the last 2 years by Apple, and they continue to update it when they add new features. This is actually a really, really helpful resource. If you haven't seen it, check it out. You can send it to your clients. You can send it to your users. It really explains a lot about how Apple, as a company building a platform, takes security very seriously and what they do to make their platform secure. So now that we're working on this secure platform, what are the things that we can do as application developers to build on top of that? Like, what are the extra things we can do to really make sure that our apps are a bit more secure just than what's provided by the platform? So the way that I kind of talk about security is in terms of user information. So my definition of security is that it's all about being responsible with a user's information, that a user has downloaded, they've bought or obtained freely your application, and they're choosing to trust you with their data. So the type of data that your app deals with really kind of defines how secure it needs to be. We recognize that not everyone is building a banking app. There are many different types and varieties of applications in the App Store, but security is really best tailored for the type of app that you're building. That we are all shipping software. That's the reason that we're all here. We all love to build mobile applications. And so in order to do that, we have to make trade-offs, because the most secure app in the world isn't really of any benefit if it never ships. So everyone is shipping software. Security is all about making trade-offs. And it has to be a balance between a really, really high, delightful user experience and still providing the security requirements that it needs to be effective and safe in the marketplace. So that leads me to the kind of main discussion point, security best practices demystified. And it's really the 10 things that I think we can all take away to help us build more secure software on the iOS platform. So, jumping right in. NSLog, I'm sure we're all familiar with this one. And the first thing I'm sure a lot of people are thinking, well, gee whiz, logs are really helpful. You know, what could possibly go wrong? So, here's one little example. Seen this before. Maybe, hopefully none of you have, but I have. There's a little line right there. They're logging the username and password just, you know, to be very helpful, just to make sure that a username and password was set correctly in the login fields like they should be. But, you know, this is a serious issue because what happens if you accidentally ship these logs into production? Now, all of your username and passwords are logged out in the open. And this was actually in the news media a couple of months ago. There was a very well-known app on the App Store that did this. And so on the scale of 1 to Mashable, this is pretty likely to get you published on the front page of Mashable, but for the totally wrong reasons. So you may not want to do this. And so there's dangers associated with overlogging information, right? That you could accidentally leak passwords. You could accidentally leak sensitive web requests. It's very, very popular these days to log all of your web traffic to the console, right? That's a very, very easy way to debug some of your web request traffic. But you need to be careful with that. And the best way to really be careful with it is to prevent logs from shipping to production. And it's okay when you're building the app in debug mode to have all sorts of logs in there. You still want to be relatively safe. Like, I don't personally think you should ever log a password or a credit card. There's plenty of other ways, like using breakpoints, conditional breakpoints to print out or inspect that information. But no matter what, you definitely want to disable logs in production. And this is one of the ways you can do that. It's a little macro that you can have that defines something like a UB log or a DS log or whatever it is that, you know, some prefix that you can use. And you use that macro instead of the NSLog function so that in a release build, that just gets stripped out and it doesn't do anything. It's also a really good case for writing tests. So one of the things that we did on our mobile banking project is we actually wrote a Ruby script that would scan all of our file source code, and if it ever saw the phrase NSLog anywhere, it would fail the build. So there was literally no way for a developer to check in code that it contained the word NSLog. So if you want to be really serious about it, this is a great way to do it. And of course, I do have to give a mention to a really, really popular framework called Cocoa Lumberjack. It's got to be the best name for a framework ever, in my opinion. And it has really handy conveniences like setting different logging levels, and it's asynchronous, it's fast, it's awesome. So if you're a heavy user of logs, this is definitely something to check out. So another one is fast app switching. And this is something that a few of you may not be familiar with. But what actually happens when your app goes into the background is the system is very helpfully taking a screenshot of the currently running app so that it can populate this user interface. It's the multitasking UI, and you want to see a preview of your apps when you scroll through it. Well, the problem with this is twofold. One, it can become a privacy concern because you hand your phone to somebody else and they can see all of your information right there. But also, these screenshots are stored unencrypted on disk. So if you lose your phone, the data there can be obtained by somebody that has your phone. So there is a way to prevent this. It's a good idea for many apps to hide some information there. You can do that by obscuring views, removing them from the view hierarchy, putting up a completely different view when the app goes in the background. But I actually prefer the way PayPal does it. So if you can see here, it's not very clear, but the PayPal app is actually blurring the contents. So it's the same view that's visible that has your list of transactions or wherever you were in the app, but the contents are blurred. So you get this sense of place of where you were, but you can't read the individual numbers. So it's a little bit more private, but also a little bit more friendly. I think that's a really good way to do it. And of course, a little code sample here. This is very easy to implement. You just do it inside the app delegate did enter background method, and you can inspect the view hierarchy and make some decisions based on the current state of the view hierarchy and where the user is in the app, and then change that content however you want to. Third one is SSL pinning. In the talk earlier, I saw a relatively low number of hands go up when the question was asked how many people are using SSL pinning. This is probably one of the most effective things you can do to improve your app security a little bit. And it's a really easy way to make man-in-the-middle attacks much more difficult. It doesn't completely prevent man-in-the-middle attacks. And one of the reasons for that is it depends on the chain of trust in SSL being intact. And things like the go-to-fail bug broke that chain of trust. And so even if you had SSL pinning enabled, it wouldn't have protected you throughout the entire chain of verification that SSL performs. But it is a really good best practice to make sure you're doing in all of your apps. And really the way that this works is comparing two certificates. That you have the certificate from the server, and you can bundle that certificate inside your app, which gives you certain information about that certificate that you can verify. So there's two types of pinning. Certificate pinning is literally comparing one certificate to the other. So is this certificate equal to the other one? And it's pretty easy to implement, but the problem is that if the certificate expires, or if the web server has a rotating certificate policy, like maybe like Google, they change their certificates every month, then that means your app requires an update to continue to work. That if the certificate changes or expires, your communication will fail. That's the whole point of the pinning. So it's not very fragile. I wouldn't really recommend going down this approach in production. The safer approach, and what's considered to be the best practice for most cases, is actually public key pinning. So what you do is you extract the public key from both certificates and compare that. And it's basically the same idea, but it's not nearly as fragile. That the certificate can be updated, it can expire and be renewed, and as long as the public key remains the same, then your app continues to function normally. So this is what we use for most projects. It's worth pointing out that AF networking supports pinning both in the older version as well as the newer iOS 7 2.0 version. How many people use AF networking? Okay, a lot of people. It's the most popular Objective-C library on GitHub, so that's not surprising, and rightly so. It's a very, very helpful framework. But one thing I do have to point out is you want to make sure you're using the most up-to-date version of AF networking if you're relying on pinning. And you also don't, if you're using CocoaPods, you don't want to have that update automatically. You want to have that be a manual update process, because in the past, the SSL pinning implementation in AF networking has been broken. It's broken once or twice, and then it's been updated and fixed. So you really want to make sure that you're using a version with correct working support. There are tests now in AF networking that will help validate that, but just to be safe, I'm going to talk a little bit more about this later, but you want to make sure you're targeting to a specific version. And of course, SSL pinning could be a whole talk in and of itself. So these slides will be available later, and I've got all sorts of links that you can follow and read up about if this is something that you're interested in. All right, ArcPy. That sounds tasty, right? So an ArcPy a day keeps a memory attack away. That's just sort of my joke to talk about memory attacks on iOS. And whenever I'm talking about memory attacks, I think the first thing I want to bring up is being practical. That A, how likely of an attack is this really? And how much effort do I really need to go to protect myself against this? That to really, really try to come as close to guaranteeing as possible that you're preventing memory attacks, you could implement all sorts of other features. You could probably build a second app in that span of time. So, how much do you really need to do to prevent these kind of things? That things like scribbling over in a string memory. That's not really practical. It's very difficult to do something like that. And is it really going to stop a hacker, somebody that's really trying to crack your app? There was a great discussion this morning in Q&A about sort of the battle and kind of the game between the guy protecting the app and the guy attacking the app. And how is that going to really pan out? Are you ever going to really be able to do that? And I think with this sort of thing, it's really all about what are your specific requirements? Like, what is the best fit? What is the trade-off? And for me, the best two things to do are to use Arc. Arc is fantastic. We've been using it for several years now. And it's really just all about helping you make sure you're managing memory correctly, that you don't leave objects around that are vulnerable to attack for any longer than they need to be. And of course, also keeping PI enabled. PI stands for Position Independent Execution. I think it was introduced around iOS 4. It's actually a compiler optimization, and it is enabled by default, so you don't even have to go turn it on yourself. And just leave that on, and you're really doing, I think, what is best for your project. Next one is text fields. So one thing you may not be aware of is for text fields, when you're entering information there, and maybe you spell a word correctly, but it tries to autocorrect you to something else, and then you tap that little X because you're correct, you were very accurate in your typing, and iOS is totally wrong, that word is spelled correctly. Well, whenever you do that, it saves your autocorrected word in a dictionary. And that dictionary is open to the public. It's fair game for anybody to read the contents of that. And so if you just auto-corrected your password or your social security number or your bank account or something sensitive into that text field, well, guess what? Now that's persisted and it's open on the device. So you want to kind of disable this autocorrect support in secure text fields, and Apple has actually done that by default for you. So if you have a secure text entry text field, the ones that have the little dots that replace the characters as you type, good news, that's actually supported by default in those text fields. But if you're doing some really custom stuff, maybe you created your own text field from scratch, this is something to be aware of that you should consider disabling if you're dealing with sensitive data. Similar story with UI pasteboard, copy, paste, or copy or paste. Copy is disabled by default in secure text fields as well. And the reason being that anything that's in the pasteboard is public to any other app on the system. So the pasteboard's open, anybody can read it, and that can be an issue if you're copying and pasting passwords and usernames around. But I know that everyone here uses 1Password, I'm sure. And I'm sure the first question that many of you are asking is, how does 1Password deal with this problem? And 1Password is sort of making a couple of neat decisions, but they're also implicitly trusting you as the user that you are okay with copying and pasting your passwords around into other apps. But to be a good citizen, they are making a couple of decisions. One is they're marking content with a org.nspasteboard.concealed type, and that's sort of a good citizen convention on the Mac that things like pasteboard managers and tools like Alfred and Quicksilver will be good citizens, and they will mark those strings as obscured, and so it's letting the system know that that is sensitive information and taking the appropriate steps to protect it. And they're also expiring contents in the pasteboard, so they don't let it stay there forever. They expire it after 90 seconds, but that's also a user configurable setting. So if you only want to have 10 or 20 seconds where your data is in the pasteboard, you can control that as a user. So just a couple of thoughts about being careful with the pasteboard. And I have another reference here as well. Moving on to local storage, this is certainly a topic that I'm sure everyone is interested in. And if you really want to make a very secure app, one way to do that is to not store anything locally, right? But the problem is that cannot be the best user experience, right? It's all back to trade-offs, user experience versus security. So there's certain things that I think you should feel fairly safe storing and certain things that I think are a little bit more dangerous to store. Certainly, user-generated content, I think for the most part, is pretty safe to store locally on the device. Things like if you're making a photography app or a to-do list app, it's probably pretty reasonable to expect that the user wants you to store that content somewhere. Public content, if you're downloading maybe a public-facing website or something like that, a public API, like Twitter or Facebook, it's probably fairly safe to store that information. Certainly media apps like podcast clients, I think it's very safe to store that on the device. And also application preferences, metadata, stuff that if somebody gets access to, it's really not a big deal. Where you need to start really kind of second guessing is when you get into personally identifiable and sensitive information. Certainly things like medical information, financial information, these are fairly obvious. Copyrighted content, if you're building an app that consumes copyrighted information like videos or books or PDFs, things that maybe other people don't have access to, or there's digital rights management controls around, you have to be very careful with how you store that on a device, whether you don't store it at all or you store it encrypted. Corporate information, if you're building an app for a company, say for document management or for somebody's sales team, there may be proprietary data that they don't want you to store on the device or that they need you to store encrypted. And HTTPS traffic. So this is another thing you may not be familiar with, that all of the HTTPS traffic that comes in over NSURL request is actually cached locally on the device by default on disk. And it is protected with the data protection APIs, but that's something to be aware of, that if you have really sensitive web requests, you may want to disable that caching. So a couple of things that you might want to think twice about storing or not. And I wanted to tell a little bit of a story here about local data storage. There was an app we were building recently where we wanted to support background downloads of content. So the user could have a list of files, then they could be of any size, 5 megabytes, 10 megabytes, 20 megabytes. And now with iOS 7, we have support for background download tasks. So the NSURL session download task will function in the background. The catch is that the content we were downloading was needed to be secure. It needed to be encrypted at rest on disk. And unfortunately, the download task does not give you any kind of callback while the data is being downloaded. It's just dumping those bytes on disk, and you get a callback at the very end that says the file is done. Here you go. Here's the link to the file. But we had no ability to continuously encrypt that data. So we had to make a trade-off. We had to make a decision. Either we could support background downloading of the file and not support encryption, at least throughout the download process, or we couldn't support background downloads, but we could continuously encrypt the file at all times while it was being downloaded. And we ended up going with this one, actually, the option to support background downloads and not support encryption until the file was finished being downloaded. And our reasoning was that the user had taken a specific action, they had asked to download the file, and since they had asked to download the file, and the app is also passcode locked, we could legitimately assume that they were still in physical possession of the device. So this small window of time where the file is theoretically vulnerable, we decided that was okay. And this is just one example of kind of the decisions and trade-offs you have to make when designing and developing a secure product. You have to make these decisions between usability and security, and in this case, we chose the more user-friendly route. I wanted to give a nod to in-memory core data. This is something that not everyone really thinks about when they're building their app, but let's say that you really do want to have the benefit of core data. You want to have the object graph management features, you want to have the sorting and the fetching controls, then you can use the in-memory store. It's actually quite friendly to use. It's very fast. It's all the same benefits of core data except persistence. And for some projects, this is actually a really good option. So definitely consider that if it's kind of a high security, sensitive data type of app where you kind of want to have a database of some sort, but you can't persist anything to disk. This is a good thing to consider. And of course, everyone's favorite, the keychain. And the big thing with the keychain is that A, the device needs a PIN code to be set for it to actually really provide much value. And also, it is still vulnerable to attack. That, like was mentioned earlier today, if the device is jailbroken, if a hacker has physical access to the device, then the keychain contents can be read freely. So you want to kind of be careful with what you store here. You can still use it. I'm not saying don't use the keychain, but you can't really treat it as a place to store anything securely because it's just not. So I recommend not storing user passwords there. If you are going to store a password, at least hash it. Do something to it so it's not stored in the clear. But really the best case scenario is to store a session token. So if the user is logged in, you get back a session token, you're using a token-based authentication approach, store that token. So you can continuously reuse that session with that token, but at least the user's password is not vulnerable there. And then the next way to really support local storage is true encryption, right? And this starts out with file encryption. So there are very good security libraries, Common Crypto, on the iOS platform that support all forms of encryption. Certainly AES is a very popular one. And you really want to make sure you're using a user-generated encryption key wherever possible. You certainly don't want to store the encryption key in the keychain. That's probably the last place you want to store it besides NS user defaults. And this is a really good approach. I mean, there are very many cases where we've encrypted files on disk using AES-256. It's pretty quick on iOS. I think ARM supports some of the instructions that make AES operations very fast. So feel free to use this. There are many, many applications that make very good use of file encryption. And of course, when you're considering encryption, I think it's important to pass the salt. And a salt is something that you add when you're encrypting an object. And what the salt does is it helps you defeat rainbow tables. So the kids in their basement have these giant databases where they've pre-computed all the known passwords for everything. And if you have a salt, then that rainbow table is no longer really valid. So definitely use a salt. I think actually a really good one to use is the device vendor identifier, which is specific to every app and may be able to access, but I think it'd be very difficult. So it's kind of a good little thing to use if you're doing your own encryption. You can use that as a way to help improve that a little bit. And also the data protection APIs that are provided by Apple. Apple does want to do its best to make encryption and file protection very accessible to all developers. I think that's one of the core things in their overall security strategy, is making this very easy for all of us to do. The data protection APIs are super easy to use. There's different levels of access that you can set on a file. It was introduced in iOS 4, but it's actually enabled by default now in iOS 7. The catch is that the default is sort of the weakest option. It's the after first user authentication. So if the user has turned on their phone and they've logged in once, all of the files are now available. So there are like slightly more advanced options, like the file is only unencrypted whenever the device is totally unlocked and it's on. So, you know, something to think about there. The default may not really be the way to go. It's actually, I think, not a good idea to rely on the default data protection implementation. Apple recently published a legal policy guidelines document. A few people have seen that, most likely. And inside of there, most of the content that you would think would be covered by something like this is information that they can provide to law enforcement if they are issued a warrant to search the device. So you definitely can't rely on this type of encryption for everything. And of course, another option is encrypted core data. We've used this on a couple of projects, and you know, core data plus NS incremental store plus encryption, you know, what could possibly go wrong? So I think it's a good thing to keep in mind that if you need it, it is an option, it is available, but it may not be the best for every use case. We've definitely had a lot of issues using one of the open source implementations of this. It had a couple of bugs. We've contributed back some help to it, but it's, you know, it's not just a given that if you need an encrypted database, this is the first thing to try. There are several implementations out there that you can check out, but I think that I would treat this option with a little bit of skepticism and decide how badly you really need that encrypted database. A couple more resources. All right, third-party libraries. The main thing to keep in mind here is hope is not a strategy, no matter how much we wish that it were. that really when we're building an app, we're responsible for the whole app, not just the code that we wrote. And when, we're all, I think, very much fans of the open source community. The Objective-C iOS open source community is very, very good. I think it's one of the best I've ever seen. But we, as the developers that are shipping our products, are responsible for what's in them. So if you're using open source third-party code, it's up to you as a developer to verify what's in there, to inspect the code, to look at the behavior, to inspect the logs that are being dumped into the console, to look at web traffic, to look at files that are being stored on disk. And if you are following all of these guidelines in your app, make sure that all of your third-party code is as well. I think that's really the best thing to do. And, great example of this gone really, really bad. How many people are familiar with Heartbleed? I think a lot of you. So, OpenSSL, a third-party open source framework, it's still vulnerable to these kinds of issues. And the best thing I've seen throughout the entire last couple of months about Heartbleed is this quote from John Callis, who worked at Apple, that it's really all about saying that Heartbleed is not a crypto problem, it's a software engineering problem. That managing a third-party open source library like this that is complex and has as deep a structure as OpenSSL is very hard. And it's the same thing for us when we're building software, that we're building complex mobile applications, and that kind of demands a very robust, excellent set of software engineering practices. So I think if you don't take anything else away from this talk, I think one of the best things that you can do to improve the security in your app is to have really, really good software engineering practices, that you have a very robust approach to testing, to acceptance criteria, to making sure that everyone on your team has an understanding of what your dependencies are, what features your app is supporting, what its business goals are. That having really excellent software engineering practices, including code reviews, I think will really be the thing that makes your apps the most secure. And finally, have a backup plan. If all else fails, if everything goes wrong, if you ship a critical security issue, have a way to recover. Have thought about that ahead of time. Have something that you can fall back on, some sort of plan for what you can do when the worst happens. And one of the things you can do is force an update. It's a very, very heavy hammer, but when your app launches, you can make a call, and that call can return the minimum version required for that app to continue running. And if it's less than that number, you can pop up an alert view, and that's it. And that's all you get. And you can link to the App Store and force the user to update. Wouldn't be very hard to implement something like that, but if you're building an app that really relies on security, and if something really bad ever does happen, we hope that it doesn't, but if it does, then this is something that you can do to recover from that, to make sure that the worst doesn't impact your users any more than it needs to. So I have a few additional resources. There's, of course, all kinds of helpful information about security out there, so I encourage you to check those out. And I'll just leave you with this: secure all the things. And thank you very much.